Hello, everyone. In this video, we are going to look at vertical shifts. So a vertical shift is a type of graph transformation in which we are sliding our graph up or down, hence the word vertical here. So also recall vertical values are often called Y values for our graph. So to get a sense of how to vertically shift a graph, let's look at an example. So in this example, it says complete the table using the function values for f. What happens to the graph in each case? Then sketch and label the graph of y equals f of x plus 4 and the graph of y equals f of x minus 2. So first of all, let's zoom in on this table here. And in this table, we are given the output values for a function f with various inputs. So this first row just tells us the input value. Next row tells us that output value of f. So for example, this term 7 tells us that f of -3 equals 7. And then similarly down that row. So let's then look at how we'd fill in the next row. So the next row is what I would get as an output if I added 4 to the original output of f. So here in this first cell, I'm going to look at f of -3 plus 4. f of -3 is here 7. So when I add 4, I get 11. And then we can fill in the entire row. So take a moment to pause the video and fill in the row on your own. And when you're ready, let's compare answers. So the next cell here should have 10 plus 4, which is 14. Then the next cell is f of x plus 4. So we have 13 plus 4 should be 17. 11 plus 4 should be 15. And then 9 plus 4 should be 13. So now let's look at what happens to the graph in this first case where we've added 4 to our graph, or to our function rather. So what I have drawn here is our original function f of x. And so we can just check this. So at -3, or rather when x is -3, my output is 7. Is that in fact the case? Yep, if I go over here to -3, my output value here is 7. At 0, my output value is 10. At 3, my output value is 13. At 6, my output value is 11. And at 9, my output value is 9. Cool. So now let's graph this next function that we've just determined, f of x plus 4. So what do you think is going to happen to the graph of this original f of x when we add 4 to it? Our entire graph just shifts or slides up 4 units. And we can actually see that by plotting these points that we've just computed. So I'm going to put a little red star here to note that red is the graph of f of x plus 4. And we see that at -3, my output value is 11. So I count up 7, 8, 9, 10, 11. At 0, my output value is 14. So I count up 14. At 3, my output value is 17. So I count up to 17. 6, my output value is 15. So I count up to 15. At 9, my output value is 13. So I count up to 13. And then so the graph of f of x looks like this upside down lazy V here. So then to continue the in-betweens in between these points that I plotted, well, I would just connect these points. So you might want to get out a ruler to help yourself do this precisely. And so what do we observe about how the graph of f of x plus 4 compares to the graph of f? Well, what happens is we just shifted every point on our graph up 4. So now let's look at what happens when we subtract 2 from every output value of f of x. That is, look at the function f of x minus 2. So to begin, let's fill in this last row of our table. So I start with the output of f when I input -3, so it would be 7, but I'm going to subtract 2. So 7 minus 2 gives me 5. Then moving on to the next column, 10 minus 2 gives me 8. 13 minus 2 gives me 11. And why don't you continue this table? And then we'll compare answers. Awesome. So you should be getting 9 and then 7. So now let's take a look at the graph f of x minus 2. So to get a sense of that graph, I'm going to plot the points that I have in the table. So at -3, over here, I'm going to plot 5. So I'll get my green. I'm going to plot 5 here. At 0, my output is 8. At 3, my output is up here at 11. At 6, my output is 9. So I go up here to 9. And at 9, my output is 7. So I'm going to connect these points that I plotted. And then go over that again just so it's a little bit thicker. Excellent. All right, now what can you observe about the graph f of x minus 2 compared to the graph of f of x? Awesome. Well, here, what happens is our graph shifts down 2. And that is the story on vertical shifts, which we can summarize here in this lovely box. So the graph of y equals f of x plus k, where k is some fixed constant, is the transformation of the graph of y equals f of x. If k is positive, so bigger than 0, I'm just going to emphasize that here by highlighting, then the graph of the original function shifts up k units. And that's like what we saw with f of x plus 4. However, if k is less than 0, so if we're subtracting a number from f of x, then the graph of the original function shifts down by k units. In this way, vertical shifts are rather intuitive. If you add some fixed number to the output, then the graph shifts up. If you subtract some number from the output, then the graph shifts down. Now, this is going to be slightly different when we look at horizontal shifts. So that's why I'm just really emphasizing what is happening when we do a vertical shift. And essentially what's happening is every output value, we either add some number to it, so it just goes up, or we subtract some number, so that number goes down. So let's take a look at the next page where we just have some more examples. So in this example, I'm given a function, y equals a function of x, g of x. And so just some observations here. So my domain goes from 2 all the way to 3, 4, 5, 6, 7, where we don't include 7. It's just a graph here of this line. So what happens now if I add 2 to the output values of my function? So that is, I look at the function g of x plus 2. Well, to get started here, I'm first going to plot g of x. So I'm going to label my axes 1, 2, 3, 4, 5, 6, 7, 8. So I'm first going to plot g. So I have here 2, 2. Just going to carry this over here, and I'm going to add a few more labels just to give some numbers on my graph. And I do have the numbers down here, but I just like to see them on the axes. Okay, so there's my first point. I'm also going to plot this point, and this open circle just to give me a sense of where my graph is living. So then I'm going to plot 3, 4. So I go over 3, up 4. Good thing I'm labeling because I missed my 4. So we have 3, 4. Then I have 5, 4. So we go over 5, up 4. Then I have 7, up 2. So my original function, the graph of my original function rather, looks like this. Remember, I have my open circle there, so I'm going to change that. Okay. Alrighty. So that's my original function, g of x. So now if I add 2 to g of x, then as we saw in that summary on the previous page, what happens is every point on my graph is going to shift up 2. So what I'm going to do is take every point, I'm just going to dash up 2 points and then plot. Dash up 1, 2, plot. 1, 2, plot. 1, 2, open circle. So now connecting the dots, I've plotted my new graph, which is just a vertical shift up 2 from my original graph. Awesome. Let's look at another example. So now I want to compute g of x minus 4. So similarly, I'm going to label my axes. I'm going to have 2. I'm going to get off of the shape feature there. All right, so I'll label 2, 4, 6, 8, -2, -4, -6, -8, 2, 4, 6, 8, and then some negatives as well. All right. So just to get a sense of where my graph will land, I'm going to subtract 4 from each output value of g. So that means my 2 would go down 1, 2, 3, 4. Down here at -2. My 4 would go down here at 1, 2, 3, 4. This 4 output would go down 1, 2, 3, 4, etc. 2, 3, 4. So my graph should look something like this. So let's go ahead and do that on my new set of axes. So just to get us centered here, I'm going to plot my original G. So I'm at 2, 2, 3, 4, 5, 4, and 7, 2. And connect my points. So then my new graph, g of x minus 4, is going to go down 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Open circle. And then I just connect those dots. All right, and so this final shift here, I'm looking at g of x plus 2 minus 3. So what I could do is start with my original g of x graph, shift it up 2, and then down -3. But we see here that this is equivalent to g of x plus 2 minus 3 just gives us a -1. So rather than shift up and down, we can just shift down 1 unit. So similar to the other ones, I'm going to label my axes and then draw my graph. So what I'd like you to do is pause the video, and then when you're ready to play, you can compare your work. All right, so our graph should look something like this. Our original function, g of x, is here. And then when we subtract 1, g of x just shifts down 1. Awesome. All right, great work, everyone, on those vertical shifts.